You ready? Today, we are doing geometry proofs. Again, there may still be some algebra in your geometry proofs, but it's going to be more geometry. So when you are working these proofs, we're still doing 2-column. That's going to be our focus the entire year is 2-column proofs. When we're doing them, your goal is to look for, sorry, let me get to the page that you do have. Your goal is to look for the reasons. That's your biggest thing, is you're trying to figure out, they're going to give you a hypothesis. It's going to be your given. And they're going to tell you what the conclusion's supposed to be. And your goal is to come up with the step-by-step process that takes you from what's been given to what you're trying to prove. Okay? Just like with an algebraic proof, you have an equation, you know your goal is to get x equals, and you go through the steps to get there. The hardest part is coming up with the definitions, postulates, properties, or theorems that you're going to use. So I would remind you, we have 50 vocabulary words from chapter 1. We now have 23, did I say? 23 vocabulary words from chapter 2. So it might be one of those definitions. Those are all nicely in your back of your book in your glossary if you need to look something up. I showed you where your postulates and theorems are located in the back of your book. So when you're working these proofs, you may want to just open your textbook to the back so you can scan through those names of postulates and theorems. Properties, we just have the ones we learned yesterday. So not any extra properties thrown in there. And then that's it. Those are the things you're going to be using for your reasons. Again, the hardest part for pre-AP kids is that you can't skip any steps. So you have to think, what does this definition tell me? So now what do I know next? And the way this is all related is the if-then idea of our statements. If they give me this, what can I now say? What does the then say? What's my conclusion? Okay? So we are going to baby step into them. They are going to give you proofs that are all done, and all you have to do is come up with the reasons. And eventually, we're going to get to blank ones where you have to write the whole proof all on your own. But for right now, it's going to be some fill in the blank. Some of the homework problems are going to be all the statements are given, and you have to list all the reasons. Some of them are going to have some statements and some reasons, and you've got to fill in where those holes are. Okay? And then we'll get to doing the complete all by yourself. So what you'll notice is mine looks different up here than yours. Yours has steps listed, right? Okay, so remember that when you're doing these proofs, you're going to have 2 columns. What's the left side titled? Statements. No abbreviations. Make sure you label it. Second side, reasons. Okay, so it says write a justification for each step, given that angle A and B are supplementary and the measure of angle A is equal to 45 degrees. So they are telling you all of that is given. Okay, I can't show what you have on your paper up here because when I do, the answer comes up beside it. So can I borrow yours really quick? I'm going to list what you have up here. Sorry, bear with me real quick.
You're doing the wrong one. You're doing the wrong one.
Just kidding. So sorry. Whatever. Oops, that's not too bad. Okay, here we go. Sorry about that. So these are, I want to go back to what Caden asked yesterday about, is the first step always your given? A lot of the times the first step is your given. Sometimes it's somewhere else in your proof, and sometimes they give you multiple givens, and they break it up. They give you part of the given at the beginning, and then they don't need the other part till later in the proof, so then they write the other part somewhere else. It is crazy how many times students go to work on a fill-in-the-blank proof, and they get stuck on a part, and they have no idea where it came from, and then they realize, oh, it was given all along. So my advice, when you're working these fill-in-the-blank ones, is go ahead and find your given first. Where does it say that angle B, angle A and angle B are supplementary? Okay, in number 1, right? So what is the reason for number 1? Given. Is that the only thing that was given to us? No. Angle A is equal to 45 degrees, and that is still part of number 1 here, right? Okay, so all the given is in step number 1, but I would warn you, I promise you there's going to be proofs where they put part of the given in number 1, part of the given in number 4, part of the given in number 7, because they're not using the parts until later in the proof, okay? So you would write given multiple times as your reason wherever it's given, okay? It depends. Like there are some that may be 15 steps long. There are some that are less, and there are some that you're going to write that you may do it a longer way than somebody else who remembers a shortcut will do it. So it's just kind of subjective depending on what your thought process is. Okay? There won't be anything bigger than that. Oh, good grief! I have no idea. We had lots of proofs in college, but proofs were not my strong point. So I was in my professor's office hours a lot when I was in college, but yeah. Remember, we'll talk more about what's on the test next week, okay? Let's get back to this, because we're never going to get done if we keep asking questions. No, there is only one reason for each step, okay? Number 2. So now here's what you're going to do every single time, okay? Listen carefully. You are going to read what you have in your given. And you're going to ask yourself, how do I know, based on what's been given, that number 2 can be said? If there isn't an answer, if you're like, I have no idea, number 1 does not give me anything that makes me think number 2 is this, then you're going to go to the picture and look at the picture and ask yourself, is there something in the picture that tells me, oh, I can now say this? For example, yesterday, the first thing we noticed was looking at the picture, we could use segment addition postulate or angle addition postulate. So we had to go from our picture to start. Here, they tell us A and B are supplementary, and then they say that means A plus B equals 180. What tells us that if they're supplementary, they add to equal 180? It's not angle addition postulate. That would be a picture where you have an angle and an angle that are adjacent and touching, making a straight line. What up here tells us that now that means they add to be 180. Okay, the word supplementary. Remember that your reason is going to be a definition, a postulate, a theorem, or a property. So you will write things like definition of, angle addition postulate. So you would write definition of supplementary. You are explaining the reason why you can say what you're saying. So if they tell you they're supplementary, you now know that means they add to be 180 because of the definition of supplementary. You're just backing up your steps. These reasons are going to be definitions, theorems, postulates, or properties. That's it. Okay? All right, so then look what they did to get from step 2 to step 3, and keep in mind they may have used something from step 1. They substituted. They said that if A is equal to 45, I can replace just this part of the left side with 45 degrees. So this would be substitution, property, and I heard somebody say it, of equality. Okay, make sure you're putting that. Then you're going to look at step 3 and ask yourself, how do they get to step 4? Good, they just subtracted 45 degrees to the other side. So this is subtraction property of equality. And that's it. There'll be some easy, there'll be some hard. We're going to build our way up to the hard. But I promise you, when people say that proofs are hard, it's mainly because they don't know their definitions, theorems, postulates, or properties. If you know them, it's not hard. You're looking at what they give you, and you're taking the keywords and what's given and making your conclusion. Does that make sense? All right, let's practice. We're just going to do lots of problems to practice and to review some theorems and postulates that you might need to use. Okay, this one is set up where I can do what we talked about. Remember on the homework, you're going to create a T-chart though, 2 columns, statements, reasons. Again, number your reasons to match your statements. Read what they gave you at the beginning. Given that B is the midpoint of AC and AB is congruent to EF. Find your given first if it's a fill-in-the-blank proof. Which numbers are the given? Okay, 1 is B is the midpoint of AC, so that is given. But notice that we also have AB is congruent to EF, and that is where? Number 3, so 3 is given. And if you don't do all your givens first, you're going to be the one sitting there struggling with what's the reason for a step, and come to find out it was just that it was given all along, okay? So be careful. All right, number 1, B is the midpoint of AC. So we look at the picture, B is the midpoint of AC. How do we know that that means AB is congruent to BC? Definition of midpoint. It's not rocket science. Don't make it harder than it is. Look for your keywords. So you say definition of midpoint. Every time if it's a definition, you say definition of, and you list the word that it is the definition of. The other thing I would warn you to do, and right now you're going to go, I don't need to do that because these are too easy. They're going to get harder. The best thing to do is to mark your picture. Mark your picture. So now we know this AB is congruent to this BC. Super important that you mark your diagram as they get harder, okay? So now let's see what we have. Don't skip over the parts that are given, though. You need to read those to help you reason through why you know what you know. So AB is congruent to BC. Now they said AB is also congruent to EF. So how do we now know that BC is congruent to EF? Okay, so this has to be a definition, theorem, postulate, or property. It is transitive. Remember we learned yesterday that if you have something congruent to something, I'm going to just circle this, A is congruent to B, and that B, the same thing, is congruent to something different, you can combine those two parts, right? Okay, and it's transitive property of congruence. Making sure that your symbol matches what's in your statement. If it's an equal sign, it's equals. If it's congruent, it's congruent. We doing good? It's really not that bad, right? I know, it's not that bad. It's going to be all right. It's going to get harder, but we'll do the hardest one at the end together and talk about it. Okay, theorem. We've already learned a couple theorems. You walked in here knowing the Pythagorean theorem, and then I taught you another theorem called the vertical angle theorem. But it was before the book actually teaches it. So I had to teach it to you because you had to use it on one of the homework assignments knowing that the vertical angles were congruent. A theorem is not accepted as true without proof. That's postulates. We just believe them to be true. A theorem is something you can prove. So every theorem that we learn in this class has been proven true. There is a proof to back it up. Okay? So here is another theorem that you're going to need to know. We'll use it quite a bit, okay? And I try to point out the ones we use a lot, like angle addition, segment addition postulates, we use those a lot. Linear pair theorem. So linear pair theorem says, and I love the way they set these charts up, because this is how it's going to be. If this is one of your statements in your proof, and this is another statement in your proof, then this could be, or excuse me, just kidding, go back. If this is a statement in your proof, then this could be the next statement in your proof, and this would be the reason. So let me explain what it says. If two angles form a linear pair, So if somewhere in your proof you have angle A and angle B form a linear pair, that's one of your statements. This theorem says if they form a linear pair, then they are supplementary. So your next statement you could write if they give you this somewhere in your proof is that now angle A and B are supplementary. This is exactly what you would write as statement number 2. And the reason that you can say that is the linear pair theorem. So think about it. If two angles form a linear pair, here's a linear pair. This is angle, well, they really can't be called angles A and B because that would be a different point here. But anyway, here's an angle, here's an angle. They form a linear pair. Do you agree that they're going to be supplementary? Okay, and we've talked about that. We just didn't give it this name. Okay? So keep that in mind. You'll be using that. Here's another theorem, congruent supplements theorem. So again, the hypothesis could be a statement that's somewhere in your proof. I'm going to say statement 1, but it might be statement 5. It could be anywhere in your proof. Your next statement would be this conclusion, and the reason you can say it would be this theorem. So let's go through it. It says if two angles are supplementary to the same angle. If two angles are supplementary to the same angle. So that could be a picture like this. Okay? So if you look at this picture, would you agree that 1 and 2 are supplementary? Would you agree that 2 and 3 are supplementary? So that means that angles 1 and 3 are supplementary to the same angle 2. Right? Okay, so if in your proof somewhere they tell you that 1 and 2 are supplementary and 2 and 3 are supplementary, so that 1 and 3 are supplementary to the same angle, it's kind of like the law of syllogism again, okay, but it's going to be different because it's not dealing with if-then statements. Then what we can say is if 1 is supplementary to 2 and 3 is supplementary to 2, what does that mean about angles 1 and 3? They're not supplementary to each other. They're congruent. They're congruent. So this is like if this was 150 and this was 30. This is 150. These are supplementary. These are supplementary. So therefore, these two have to be congruent. So if you see this in a proof that you have two angles supplementary and a different two angles are supplementary, but they're supplementary to the same angle, then that means the ones that were supplementary to the same angle are now congruent. And it's called the congruent supplements theorem. So the name kind of helps you think about it. If 2 are supplementary and another 2 are supplementary and one of them is the same angle, then those other ones have to be congruent. Okay? Or, I want to emphasize this, it could be that they're supplementary to 2 congruent angles, so that the picture looks like this. Are 1 and 2 supplementary? Are 3 and 4 supplementary? Okay, but what do we know about 1 and 3? They're congruent. So what does that mean has to be true about angles 2 and 4? They have to be congruent too. Again, think about it. If this is 30, then this has to be 30. And if these are supplementary and these are supplementary, the only way that's possible is if 2 and 4 are both 150, right? So it means if two angles are supplementary to the same congruent angle, or if they're supplementary to congruent angles, then this is true. Okay, this is where you've got to study this and make sure you've got the name down. Congruent supplements theorem versus linear pair theorem versus vertical angle theorem. You've got to know what all those theorems say. Okay? All right, we already know what a two-column proof is. I made this easier for us today by starting it yesterday with algebraic proofs. Two-column proof, you just list the steps of the proof on the left, and then you write the matching reason on the right. Okay, we did that yesterday. So here we go. Another proof where we're going to try to fill in the blanks. This is typically how your geometry proofs will look. They'll have a picture. They will have a part that says given, and then the things that are given. And then they'll tell you what your goal is, what you're trying to prove. The prove should be your very last statement every time. So if I come down here and this is empty, my last step, there's no guessing what that should be. Whatever they're telling you to prove, that's what your very last statement should be. You're not done until that's your last statement. So right now, just looking at this, what do I know has to go for number 6? Okay, so this has to be angle 1's congruent to angle 3. So again, these fill-in-the-blank proofs can be a little bit easier because there's some things you can use to figure out what has to go there. Okay, the other thing we want to do is make sure that we have filled in all of our given as reasons and that they're in the right spots. So it says 1 and 2 are supplementary and 2 and 3 are supplementary. I see one word given over here, and I don't see any other thing that says given, right? We're missing number 5. 5 could be given, but is what the statement is one of our givens? No, it's something different, right? You guys with me? So 5 can't be given because it wasn't listed up here, which means are they putting all of this in step number 1? Yes, because there's no other given over here, and the only spot that's blank is not our given. So what is number 1 going to be? Okay, and? Okay, so we're going to put all of this right here for number 1. Okay, so angle 1 and angle 2 are supplementary. And you may not have room to cram it in your box, so you may want to write it over to the side like 1, and then here's the statement. So 1 and 2 are supplementary, and angles 2 and 3 are supplementary. All right. When you're doing your homework, you have to write the whole proof every time. Even if it's fill in the blank, you do not get to just list what goes in the blank. You have to write the whole proof every time. Are you guys with me? Every year I have students who turn in a piece of paper and they have it look like this. 1A, 3C, 4D, and they've just listed their answers. You will get points taken off. You are not allowed to do that. The whole goal is for you to think through the entire proof, so you're going to write it all down every time. Okay, so let's follow what they did and see if it makes sense, because you eventually would have to get from the given to the prove all by yourself with nothing on the paper. Okay, so given 1 and 2 are supplementary, 2 and 3 are supplementary. They next said that means 1 plus 2 equals 180 and 2 plus 3 equals 180. And what is the reason they gave? Definition of supplementary. You can just put that, or you can put supplementary angles. This is their symbol for angles, but you could have just put definition of supplementary. Do we all understand how we got from 1 to 2? Okay. Then they tell you to use 3, and this is why I don't let you abbreviate, because sometimes it's confusing. Are they saying subtraction or substitution? Substitution. So if you were doing this, you are not allowed to abbreviate. You would fill that in as substitution, property of equality. And on your homework, even if they abbreviate, you're going to write it all out. So you've got to decide, what do I use by substitution? And actually, this is one where I would say they did it incorrectly. It shouldn't be substitution. It should be transitive. So change it to transitive. And there's a couple places where they've got some mistakes. If I use the transitive property here, what could I say in step number 3? So look what you have in 2. 1 plus 2 equals 180. 2 plus 3 equals 180. Not 1 plus 3 equals 180. Transitive, remember, says if you have A equal to B, so this side is exactly the same as this side, then A equals C. And they may have it flipped over. It could be if A equals B and C equals B. Still, these are the same. Then A equals C. 1 is not equal to 3 yet. Just using transitive. What's the part that in each equation you see the entire side is the same? Look at the 2 equations. What part of those equations has the entire side of the equal sign, on one side of the equal sign, exactly the same? Say it again, Elena. 180. This is not exactly the same as this. The whole side of the equation has to be exactly the same. This has a 1 and a 2. This has a 2 and a 3. Those are not the same. But 180 is the same, right? So this is like your B that they have in common. So get rid of it. Don't mark it really out on your proof when you're doing them for homework because you're not supposed to show work on your proof. But think, that's the same, that goes away. So this is like your A equals B, B equals C. So now you're going to say A equals C. So we should say measure angle what? 1 plus measure angle 2, not plus, equals measure angle 2 plus measure angle 3. Again, this is your A, this is your C. And the transitive property says A equals C. If they have something identical in common, it has to be the entire side of the equation for you to use it. Okay? So transitive property of equality, we have 1 plus 2 equals 2 plus 3. Look what they did in number 4. This is where they use reflexive property of equality, but I am not going to make you do step number 4 if you're writing the proof out all by yourself. It's not necessary, but this is what they say. They're getting ready to do something with this equation in number 3, and they want you to understand that the measure of angle 2 on the left side is the same as the measure of angle 2 on the right side. So just making sure you know, 2 is equal to 2. That's the reflexive property. I do not make you do that if you write it by yourself, okay? So you wouldn't have to show that step. If it's a fill in the blank, you have to do what they do. So 2 is equal to 2. Now what do they do to get from 1 plus 2 equals 2 plus 3 to 1 equals 3? It's not transitive, it is subtraction. They are subtracting away the 2. And for that to work, the 2's have to be the same. So they're just making sure you know, hey, the 2's are the same. So when you subtract them away, they really do go away. So what's my reason for number 5? Subtraction property of equality. And then this last step is super important, so don't skip over it. You're going to have to do this a lot. If they're equal, what tells me that if their measures are equal, that the angles are congruent? The definition of congruent. Remember that we said, not last class, but the class before, all definitions are biconditional. So that means that these can go in either order. There is not a definition of equality. We have not talked about equal, definition of equal. It is the definition of congruent. So sometimes you're going to have to say things like, AB is congruent to CD, and then your next step is AB equals CD. If they're congruent, what tells me that means they're equal? The definition of congruent. Or you can go the other direction. Maybe they tell you AB is equal to CD, and you need to say AB is congruent to CD. What tells me that if they're equal, then they're congruent? Definition of congruence. It goes both directions. It's biconditional. Okay? So if you need it to say equals, but it's in congruent form, use the definition of congruent, and vice versa. So that's what they did. They wanted to prove the angles were congruent, not equal, so they had to use the definition of congruent. Okay, couple more theorems. And the hard part is you're going to learn a lot of theorems as we go. You've got to study them, okay? Right angle congruence theorem is awesome. It saves us a lot of time. If you don't remember this theorem, you're going to have to show like 4 steps in a proof that you wouldn't have to show otherwise. The right angle congruence theorem simply says all right angles are congruent. So again, if you were in a proof, somewhere in your proof you would have that you have 2 right angles, A and B. Your next step could be those 2 angles are congruent. And the reason you can say that if they're right angles, then they're congruent is the right angle congruence theorem. Memorize the name, right angle congruence theorem. Okay, and the last one here is the same as the one we talked about a few minutes ago, but we were done with supplementary. Now it's complementary. congruent complements theorem. So once again, a picture that you might see could look something like this. You have two angles, 1 and 2, but then you also have another angle here, 3. So do you see? That's a box. Sorry, I made it really tall so you could see it above the other one, but it is still a right angle box. So 1 and 2, would you agree those are complementary? 3 and 2, complementary. So what does that mean about angles 1 and 3? They're congruent. And again, this is how it would look in the proof. They would tell you 1 and 2 are complementary, 2 and 3 are complementary, so therefore 1 and 3 have to be congruent because they are complementary to the same angle. Again, it could be that they're complementary to congruent angles, so that you have two separate pictures like this. 1 and 2 are complementary. 3 and 4 are complementary. But then they tell you angle 1 and angle 3 are congruent. So what does that mean about angles 2 and 4? They're congruent. That's the congruent complements theorem. Are we good so far? Okay, because notice what's coming up. Do you see on the next example down below that we have a completely all by ourselves proof, right? Okay. Really quickly though, in this little helpful hint, I've already said this, but I'm going to emphasize it again. In a diagram, if a diagram for a proof is not provided, that means if they haven't given you a picture, you should probably draw yourself a picture. But we've been doing that all along so far. And mark the given information on it. The number one first step every time should be to mark the given on your picture. Mark what they give you. Tick marks, arc marks, fill in the information. Whatever they give you, mark it on your picture. Okay? It's going to seem not necessary when the proofs are really easy, and then they're going to get hard, and you won't be able to do them if you don't mark your picture. Okay? Never, ever, ever mark what they tell you to prove on the picture. You don't know that yet. That's your goal. Do not ever mark what you're trying to prove on your picture until you get there at the very end. Okay? So mark your given, start your proof, mark things as you figure them out, but don't ever mark what you're trying to prove. That's your last statement. Okay. It says, use the given plan to write a 2-column proof. I'm going to warn you, you will never have a question on your test that says use the given plan. I won't give you a plan. You don't have a plan, right? If you look at your paper, do you guys have a plan written down? No. This is not on your paper because I'm not going to give that to you. However, as we're learning on the homework, you will have some on your homework where they have a little plan written out. It's basically telling you exactly what to do. So try to ignore it and see if you can do the proof first. And then if you can't do the proof, look at the plan and see if it helps you. Okay? But on your test, you won't have that. So it's just kind of a little stepping tool. All right, so let's see if we can do this. I provided you a 2-column proof to the right. Does everybody see how that's already there for you? Okay, so we're going to make our proof. Statements. Reasons. Number 1, what's the first thing that we want to write down? Given. You may want to put all your given. You may want to wait and break it apart. I often find students do better if they write down one given and then try to see what do I know from that given and then write down their next given. So we may try it that way and see if it helps you. So first we know angle 1 and angle 2 are supplementary. Reason is given. Okay, I'm not going to write the next thing yet. I want you to tell me, what do you know now if 1 and 2 are supplementary? Okay, and use correct notation. So measure of angle 1 plus measure of angle 2 equals 180 degrees. How did we know that? Okay, so make sure you write definition of supplementary. And again, the more we do together, the more these things are going to be easier for you on your homework because we will have reviewed what to do in the notes. All right, from there, there's not really much else I could do, so now I'm going to bring in the other given. So number 3, I now know angle 1 is also congruent to angle 3. Given. I also should come over here and mark my picture. This one isn't, again, it's not going to seem super helpful today, but as they get harder, you're going to see it's really helpful. But I'm going to go ahead and mark it. So 1's congruent to 3. And I know that 1 and 2, these two angles are going to add to be 180, right? Okay, there's not really a way to really mark that other than writing it, and I've already written it here on my proof. Okay, so what is our goal? What are we trying to prove?
3 and 2 are
That 3 and 2 are supplementary. And right now I have 1 plus 2 is 180, and I know 1 is congruent to 3, and I want 3 and 2 to be supplementary. So what do you think we might need to do here? Okay, we need to substitute. Substitute what? The 3 in for the 1, but here's the problem. There's not a substitution property of congruence. There's only a substitution property of equality. And you can't take something that's congruent and substitute it in somewhere when you've got an equal sign. So first, you're going to have to switch this from congruence to equality. And remember what we talked about. What tells me that I can go from equals to congruence or congruence to equal? Definition of congruence, and you're going to use it a lot. So the first thing we need to do is change this to measure angle 1 equals measure angle 3. Use your correct notation. And the reason we just said was definition of congruence. And you can use that little congruent symbol instead of having to write it out every time. Okay, whatever you want. Okay, so now what did Ridley say we should do next? Substitute. Plug that 3 where the 1 is so that we have 3 plus 2 equals 180. So number 5, measure angle 3 plus measure angle 2 equals 180. And what's our reason? Substitution property of equality. Stop me if I'm going too fast or you don't understand. Okay, is this what we're trying to prove? Close. Is it exactly what it says to prove? No. This has to be exactly what they tell you to prove before you can stop. So what tells me that if 3 plus 2 is 180, that 3 and 2 are supplementary? Definition of supplementary. And again, remember, it goes both directions. It's biconditional. If they're supplementary, they add to be 180. If they add to be 180, then they are supplementary. And that's why it's important you understand that all definitions are biconditional. They can go both directions. So your last step is always what they tell you to prove. Angle 3 and angle 2 are supplementary. And the reason is definition of supplementary. Can I see what you have in your notes left? Okay. I want you guys to look at the one on the back. Oops. Now, I want to point one thing out real quick before I have you try it on your own. This is the last example in our notes, and then we're going to do one problem off the homework together, okay? But I want to point one thing out. It says use the given plan. Again, I took the plan off for you because I don't want you to have that because you won't get it on the test. So pretend you can't see it up here, okay? But here's the thing I need to point out, and this might catch you on the homework, so be careful. It says use the plan to write the two-column proof if one, it should say use the plan to write a two-column proof of one case of the congruent complements theorem. They're wanting you to prove the congruent complements theorem. If you're trying to prove the congruent complements theorem, that means you can't use the congruent complements theorem in your proof. Okay? So this is, you are writing a proof of this theorem. So this is not an option for one of your reasons. You cannot use it for one of your reasons. You can use any definition, theorem, postulate, or property. but not this one because you're writing a proof of that theorem. Okay? So go ahead and start. See if you can do it. This is your given. This is what you're trying to prove. And we are working over here on the whiteboard, starting with our given. Bless you. Angle 1 and angle 2 are complementary. You may have put all of your given at once, and that's totally fine if you did. I'm going to go ahead and tell you I'm going to try breaking it apart every time to see if that helps you. So angles 1 and 2 are complementary, given. What do you know if 1 and 2 are complementary? Exactly, okay? And the reason you know that? Definition of complementary. I was seeing that a lot on your papers. Then, from there, you might have been stuck because there's not much you can do with just that. So you go back to your given. Angles 2 and angle 3 are complementary. And number 3, that was given. Again, those could have been in the same step number 1. If 2 and 3 are complementary, what do you now know? Very good. Measure of angle 2 plus measure of angle 3 equals 90. Catching a lot of you not putting your little m's. Make sure you're putting those little m's or you'll miss points every time. Number 4, same reason. Definition of complementary. Again, those could have both been in the same step 2 if you wanted to do them all at once. This could have been 1 and 3 were step 1 and 2 and 4 were step 2. Okay? Now, this is where a lot of you were getting stuck. What can we do from here? Transitive property. Notice that in statement 2, this is equal to 90. In statement 4, this is equal to 90. If one side of your equation is identical, those cancel out, and you can say this part is equal to this part. So number 5, measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. Does that make sense? Okay? The reason was transitive property of what? Transitive property of, careful, look at your symbol. What symbol do you have here? Equals. Okay? Now keep in mind your goal. What's your goal? To prove 1's congruent to 3. So what do we need to do next? Subtract the 2's. This is where you could say angle 2 is equal to angle 2 by reflexive property first if you wanted to. You do not need that step for me. I am not requiring you to say that. We are going to know if it says angle 2 and angle 2 that those are the same angle and they have the same measure. So you can go straight to subtraction property, subtract away the 2's. So number 6, measure of angle 1 equals measure angle 3. And what we did was subtract away the 2's. So subtraction property of equality. Are we finished? No. We have that they're equal, but what's our goal? That they're congruent. So number 7. Very good. Angle 1's congruent to angle 3, and the reason is definition of congruence. Does it make more sense now? Okay. I want to do one problem with you on the homework, but I also have 2 mistakes on the homework that we need to fix. Okay?